All right, welcome back to an exciting new video. So it's exciting because we're learning about the Juniper validated AI data center design. So this is supplemental study to my goal of trying to earn the CCNP. As I've talked about, I've kind of worried that the CCNP won't set me up specifically for riding the waves of this AI progress that we're going to see over the next few years. So this is my effort to fill in any gaps that might cause. All right, so now we're going to read about the solution benefits. Juniper networks stand out in supporting AI networks with a scalable, standards-based, automated approach for a range of cluster sizes. Proprietary solutions that lock in enterprises can stifle AI innovation. Juniper's solution assures the fastest innovation, maximizes design flexibility, and prevents vendor lock-in for front-end, back-end GPU, and back-end storage AI fabric networks. Doesn't that sound great? That sounds amazing. The Juniper validated design for AI is a prescribed best practice approach to deploy high-performing AI training and inference networks that minimize job completion time and ease management with limited AI resources. In this design, Juniper has integrated NVIDIA GPU, Weka storage, Juniper switches, along with the Juniper Aprista software and Terraform for automation. The prescribed design helps customers very easily build high capacity, easy to operate network fabrics that deliver the fastest JCT. Well, what is that? And maximize graphical performance units, GPU utilization. All right, so let's finish this section and then learn about JCT. This document provides the best practices and validated solution to deploy a Juniper network for an AI cluster of NVIDIA GPUs and Weka storage. The AI JVD, which stands for Juniper Validated Design, enables so the artificial intelligence Juniper Validated Design enables customers to orchestrate a training cluster systematically without a need for in-depth prerequisite knowledge of the products and technology. Advanced JVD testing by Juniper subject matter experts results in optimum designs to deliver high performance, increased reliability, and simplified troubleshooting. So let's learn about JCT, and what better way to learn than to ask the AI? All right, so what does JCT mean? Job completion time.
Junction stands for job completion time. It refers to the amount of time it takes for a job or task to be completed, particularly in the context of AI training and inference networks. In this document, the term is used to emphasize the efficiency and speed with which AI networks can process and complete tasks using Juniper network solutions.
I feel like I need to be in the habit of asking more AIs because it's the perplexity one is the one that's designed to work more like an academic researcher, so it cites all of its sources, which is nice. So and then it gives you related questions that you might want to ask if you're interested in the subject. So oh, this is a good one because I learned about Ethernet CLOS architectures before. So yeah, let's see what the answer is to this. This is traditional. Yeah, it's so crazy. It's like the things that are no longer traditional. Things are steps and steps and steps ahead. Wow. Okay. Yeah, I think I should get in the habit of using Perplexity more often. I mean, I like the simple, straight to the answer, but when I want to know more, I think Perplexity does a better job. All right, so the next section is Juniper validated design benefits. I need a quick break. I'll be right back. All right, welcome back. Feeling good enough to do maybe a shorter video. So let's see here. So we were reading the validated design. So next section is Juniper validated design benefits. JVDs are prescriptive blueprints for building a data center fabric with well-documented capabilities and appropriate product selection. JVDs must pass rigorous testing with real-world workloads to achieve validation, verifying that all products in the JVD work together as expected, mitigating the risk faced while deploying a network. The core benefits of JVDs are: number one, qualified deployments. JVDs are a prescriptive blueprint for building a data center fabric to meet the requirements of a specific use case. Juniper designs JVDs to meet customer needs based on customer input and feedback. Risk mitigation. Each JVD goes through the new product initiative (NPI) testing framework to achieve validation with ongoing automated verification in each new release. Predictability. NPI testing verifies that all products work together as expected using the specific versions of hardware and software. Juniper tests common use cases to determine the capabilities and limitations of defined solutions. Repeatability. Unlock value with repeatable network designs. Because JVDs are prescriptive designs used by multiple customers, all JVD customers benefit from lessons learned through lab testing and real-world deployments. Reliability. JVDs are quantified and integrated best practice designs based on carefully chosen hardware platforms and software versions and tested with real-world traffic. Scalable designs. Juniper designs its JVDs to scale and support the adoption of different hardware platforms based on customer requirements. Accelerated deployment. Ease installation with step-by-step guidance. Simplify deployment with guidance, automation, and pre-built integrations. Accelerated decision making. Leave behind costly bespoke networks. Bridge business and technology in designs that meet the needs of most customers and consider how features behave and operate in real-world applications and conditions. Best practice networks. Juniper validated designs have known characteristics and performance profiles to help you make informed decisions about your network. Juniper Aprista benefits. Juniper validated designs in the data center start with the Aprista software, a multi-vendor intent-based networking system, IBNS. I don't know what this D stands for. Intent-based networking system. So, okay. That's what IBNS stands for. Providing closed-loop automation and assurance. Aprista, Apstra translates vendor agnostic business intent and technical objectives to essential policy and device-specific configuration. The system continually validates user intent to ensure that the current network state does not deviate from intended network state by monitoring and flagging various anomalies in the network. The core benefits of Apstra are intent-based networking, automates configuration generation and continuously validates the operating state to the intent. Network automation. Apstra is a multi-vendor network automation platform that is continuously updated to work with the latest hardware and extensively tested using modern DevOps practices. Recoverability. Built-in rollback capability restores known working configuration. Day 2 plus management. Apstra's rich analytics capabilities, including data flow, reduce mean time to resolution, MTTR. Simplicity. Apstra simplifies network management, for example, by reducing the complexity of data center interconnection, DCI. Apstra makes it easy to unify multiple data centers while isolating failure domains for high availability and resilience. So AI use case and reference design. Oh shoot! I need a quick break. I'll be right back. All right, I'm back. Kind of a rough morning this morning, but we can make some progress here. So the next section is AI use case and reference design. And I don't remember anything about what I read in the last one. Oh, I do remember. Yeah, I don't remember anything. I don't even know if I made it this far. Let me read the prior section again because I don't know. I honestly don't know if I made it past this section. I'm pretty sure I made it past this, and I know that I read about JCTs. Yeah, I know I read this part, but I don't remember reading any of this part, and I don't remember reading any. I do remember reading this, but oh, you know what? I guess I kind of remember it more now. Let's reread this section. So Juniper Apstra benefits. Juniper validated designs in the data center start with the Apstra software, a multi-vendor intent-based networking system, IBNS, providing closed-loop automation and assurance. Apstra translates vendor-agnostic business intent and technical objectives to essential policy and device-specific configuration. The system continuously validates user intent to ensure that the current network state does not deviate from intended network state by monitoring and flagging various anomalies in the network. The core benefits of Apstra are intent-based networking, automates configuration generation, and continuously validates the operating state to the intent. Network automation. Apstra is a multi-vendor network automation platform that is continuously updated to work with the latest hardware and extensively tested using modern DevOps practices. Recoverability, built-in rollback capability, which I love about Juniper, restores known working configuration. Day 2, commit confirm. Day 2 plus management. Apstra's rich analytics capabilities, including flow data, reduce mean time to resolution, MTTR. Simplicity. Apstra simplifies network management, for example, by reducing the complexity of data center interconnection, DCI. Apstra makes it easy to unify multiple data centers while isolating failure domains for high availability and resilience. AI use case and reference design. The AI JVD reference design covers a complete end-to-end Ethernet-based AI infrastructure, including a front-end fabric, back-end GPU fabric, and a back-end storage fabric. These three fabrics have a symbiotic relationship, and each provides unique functions in training and inference. The use of Ethernet networking in AI fabrics enables our customers to build high-capacity, easy-to-operate network fabrics that deliver the fastest job completion times, maximize GPU utilization, and use limited IT resources. The AI JVD reference design shown in Figure 1 includes front-end fabric. This fabric is the gateway network to the GPU nodes and storage nodes. This critical component is where users and systems access the GPU clusters. Back-end GPU fabric. This fabric connects the GPUs that consume the large models into memory from the stored datasets and facilitate the requests coming from the front-end network. The nodes, servers in the back-end GPU fabric pass high-speed information that requires a lossless network between GPUs during learning and training events. Back-end storage fabric. This fabric connects the high availability storage systems that hold the large model training data. The back-end storage fabric must ensure seamless and reliable delivery of data to the GPUs for model learning. So here's an AI, artificial intelligence, Juniper validated design, reference design. So this is a picture of it. So it's Figure 1. So we have a out-of-band management network Now we have an image here. I don't know what this is. Oh, it's Apstra. So I guess Apstra, it's kind of like Cisco ACI, actually. I think Apstra is basically Cisco ACI. Is Juniper Apstra basically the equivalent of Cisco ACI? Yes. The answer is yes.
Juniper Apstra and Cisco ACI, application-centric infrastructure, are both software-defined networking (SDN) solutions designed to manage data center networks, but they have different approaches and features.
Yeah, they're
Here's a comparison to
basically
understand their similarities and differences. Juniper Apstra, intent-based networking. Apstra focuses on intent-based networking, IBN, which means it allows users to specify the outcomes they want, and the system automatically configures the network to achieve those outcomes. Vendor agnostic. Apstra is designed to work with a variety of network hardware from different vendors, offering flexibility in deployment. Automated operations. Apstra emphasizes the automation of network operations, including configuration, validation, and troubleshooting, to reduce operational complexity and improve reliability. Single source of truth. Apstra creates a real-time continuous data model that acts as a single source of truth for the network state, helping with real-time analytics and problem resolution. Closed loop assurance. Apstra provides continuous validation to ensure the network is always aligned with the intended policies and configurations. Cisco ACI, application-centric approach. Cisco ACI is designed around an application-centric model, meaning the network is configured and managed based on the needs of the applications running on it. Cisco ecosystem. ACI is highly integrated with Cisco's own hardware and software ecosystem, providing a seamless experience for users invested in Cisco products. Policy-based automation. ACI uses policies to automate and manage network functions, ensuring consistency and simplifying management. Unified management. ACI provides a unified management framework for both physical and virtual environments, enabling end-to-end visibility and control. Security and segmentation. ACI offers advanced security features and micro-segmentation capabilities to protect applications and data. Key differences. Vendor login. Apstra's vendor agnostic nature allows it to work with a variety of hardware vendors, whereas Cisco ACI is more integrated with Cisco's hardware, potentially leading to vendor login. Approach. Apstra's intent-based networking focuses on the desired network state and automates configurations to achieve it, while ACI's application-centric approach emphasizes the needs and policies of the applications. Ecosystem. Cisco ACI benefits from deep integration with the broader Cisco ecosystem, which can be advantageous for organizations already using Cisco solutions. Apstra offers more flexibility for multi-vendor environments. Both solutions aim to simplify and automate data center network management but cater to different operational philosophies and ecosystem preferences. The choice between them would depend on the specific needs, existing infrastructure, and strategic direction of an organization.
All right, that sounds good. Yeah. Oh, wait. What was the answer again? The answer is yes and no. They are both software-defined solutions, software-defined networking solutions. See, this is why the CCNA is like 50%, or the CCNP is like all new. It's like if you have the CCNP and you go to renew, you're gonna be shocked because it's just new, because it's a whole different, like the box does something else now. It's software defined networking. It's not whatever it was before. So like the entire CCNA is different. All right. So designed to manage, and it's not like you could have jumped ahead of this too, because it's like, it's how they're doing it is changing a lot, like from year to year, and we can see like different vendors took completely different approaches. Cisco made it application centric, and Juniper made it intent based. It's like you can't win no matter what you study. You should have studied something else, you idiot. It's like you're set up to fail. It's a gamble. There's too much out there. You can ride it all on black. You can distribute up your bets and not win as big. It's like, it's gotten so crazy with like how many different little decisions can be made, that like, it's just, you do your best, you do your research, and I mean, oftentimes most times you're probably better than not. Like if you're in tech versus if you're out of tech, you're probably going to do better if you're in tech, I would say. But if you pick the right things, you got the Pee Wee Herman magic words all over what you're doing. And the best example of that is cloud versus traditional networking. All right, so Juniper Apstra, they're basically the same thing. They're software-defined networking solutions, but they make different decisions. So Juniper yeah, policy based versus whatever else, unified management versus single source of truth, closed loop assurance versus whatever else. So see, and this is why it's like hard for me to get excited about the CCNP, because like Apstra is vendor agnostic, where like Cisco wants to lock you down. They want you to pay for, if you want to enable OSPF, they want you to buy another feature license for it. They want it to be application centric so that they can charge you for whichever specific applications you want to use. Like, they want to lock you in to only using their stuff. It's like, I'm just not sure. Like, I mean, yeah. And then intent-based focuses on the desired network state and automates the configurations to achieve it, whereas Cisco ACI's application-centric approach emphasizes the needs and policies of the applications you'll be running across your network, which is interesting. I don't think that has. I honestly just don't know enough, and I'm probably talking myself into the doghouse or whatever. All right, so let's continue going on. I'll describe a little bit. So we got the front end at Fabric. We got the NVIDIA GPU servers. They interact with the front end and the back end. Then we got the Weka storage services. They also do that. We've got some things that are exclusively part of the front end fabric, such as the QFX leaf and spine switches and the Weka management services. And then we've got some things that are explicitly a part of the back end fabric. The GPU fabric is explicitly a part of that. It runs off of QFX leaf and spine switches, but different kinds. And then we've got another QFX. This is a 5220. 5230 is only for the GPU fabric. But we've also got storage fabric. So that's interesting. And then out of band management network, and looks like Apstra is some sort of application to manage all that. All right. You know what? I'm kind of not feeling it today, and I feel like when I go off the rails, I just kind of talk myself into a hole. Saying that Juniper or that Cisco is like trying to lock you in and trying to like upcharge you on things. It's probably not a good thing to say for somebody who wants to get certified and work with Juniper gear. So I feel like this is just kind of not my day for making a video, and I kind of don't want to keep going on tangents and talking myself into a hole. So I think for what it is, for the state I'm in this morning, I think I made some good progress. So that's going to be it for this video, and stay tuned for more.